Let's look at the second video on the theory of errors. Check the description box below for the previous video on this topic so you can follow it from beginning. Now, we have this question. A sample of pure potassium chloride was analyzed for chloride ion using conductometric and titrations. The following results in percentage were obtained. Calculate the average error, the root mean square error, the variance, the probable error, the percentage relative deviation. Then we have the relative deviation in part per thousand, average error of the mean, and standard error of the mean. Now, look at everything we have here. I will summarize the formula and how to remember them. But take note of something. I want to tell us some words that are analogous to each other. Like let me say synonyms to each other. So whenever they mix any of these words for us, we will understand what it means. Now, whenever you see the word error, you can replace it. It is analogous to deviation. Remember, when your value is deviating from the true value, then you are having error. So it makes sense. Also, if you hear the word, we have error means what? Deviation. If you hear the word average, average means what? Average means mean, like we know before. So if you want to calculate the average of something, we are calculating the mean. Now, looking at this, can you now tell me another word for average error is what? Replace average with mean and replace error with deviation. What do you have? This word average error also means what? Mean deviation. Next, root mean square error. Well, root mean square. Whenever you see this root mean square, it has to do what with standard error. Another word for error is deviation, so that is standard deviation. Remember, anywhere you see the word error, replace it with deviation. That root mean square is talking about standard deviation. I'll give us the formula, then you understand why it is called root mean square. You understand that? In mathematics, whenever you hear this word root mean square, it's like you're having square roots, which is the root, and you're having square. Also, this is what we call root mean square. All right, let's move on. So we have variance, probable error. So this probable error, they can call it probable deviation. Don't forget, replace error with deviation. Okay. Next one, we have relative deviation, percentage relative deviation. Another word for it is what? Percentage relative error. So, and so on like that. So take note of this word, they are analogous or they are synonymous to each other. So in case we can learn average error here, in exam we can be asked average deviation. So don't get it twisted. Error, deviation, synonymous to each other. Now, what are the formula to get this? Before I start writing the formula, take note. We need one formula that will serve as a prerequisite, and that is the mean, x bar. So the formula to calculate mean is what? Summation x, that is the sum of all of our scores over what? Over n. Okay, let me write that straight, please. So we have x bar is equals to what? Summation x all over n. That the sum of all these values all over what? All over n. So that is it. Now, what is now the formula for what? For average error. Now, average error is denoted as d bar. So the first one, average error, is denoted as what? D bar. So what is D bar? The formula is what? Summation absolute value of x minus x bar, then all over n. When you see this absolute value, let me say you evaluate x minus x bar, you got that to be minus 3. Since this absolute value is there, you get rid of the minus, then you just have 3. So whenever you see absolute value, just remove the minus sign. So if I have minus 8, for example, minus 8 absolute value, it means 8. So if I have plus 3 absolute value, it means just plus 3. Okay, good. Now this is what we have as the what? As the average deviation or average error. Next one, what is root mean square error? Root mean square error is the standard deviation. So root mean square error is what? Is standard deviation, and it is given as what? Summation x minus x bar square, summation x minus x bar square all over n, then square root. So you can see what we call root mean square now. You have root, you have square, and something will be dividing it. Now take note. Take note. This standard deviation, otherwise called root mean square error, have something you have to keep in mind in chemistry here. Take note that what this formula is n minus 1. You are to use n minus 1 if your n is less than or equal to 30. If your n is less than or equal to 30, you are going to use n minus 1. But your formula will become s equals square root of summation x minus x bar square all over n if your value n is greater than 30. Okay, so take note, whenever, like looking at these values now, obviously they are less than 30. In exams, they will always give you the one that are less than 30. So take note that what here under statistical treatment of data in physical chemistry, you are going to be using what n minus 1 for standard deviation. And without wasting much of our time, what's the meaning of variance? If you know the formula for standard deviation, it will be so stressful for you to be learning the one for variance, because standard deviation is the square root of variance. So it means that from here, my variance is the square of standard deviation. In other words, remove square root from standard deviation, you'll be having variance. It means that what is inside this guy, what is inside this place is the variance. All right. After knowing that, jot this down. So what's formula for what? Probable error. Now, probable error has what? Has two formula. So the first one is in terms of what? Let me write it here. Probable error. Probable error. Good. So denoted as what? As R. Probable error has two formula. Is what? R equal 0.6745S. S is the standard deviation or root mean square error. Also, error can be equal to what? 0.6745x or 0.7876 D bar. Either of these two will give you your final, will give you right answer. So that's probable error. Now, next one, what is percentage relative deviation? You see, another word for relative deviation is, you see, take note that what? Another word for relative deviation is coefficient of variation. Is coefficient of variation. That's another word for what? For relative deviation. And what's formula for what? For relative deviation? What's formula for relative deviation? It is what? The standard deviation all over mean. Relative deviation is what? Standard deviation all over mean. Now, let me tell you something. You see, this is what, just to be asked to calculate relative error. Relative deviation can also be called relative error. Remember, deviation replaced with its error, same thing. So look at this relative deviation, standard deviation all over mean. You see, you can be asked to calculate this in different form. If you are asked to calculate in percentage, you multiply by 100, then you put your unit for percentage. If you are asked to calculate in parts per thousand, you see, you can be asked to calculate in what? Parts. There's something we call parts per thousand. You see, instead of you to multiply by 100, you multiply by what? 1000. 1000. But your unit will now be like this, 0 over 0, 0. Just like percentage is 0 over 0 like this one 0 over 0, 0. So that is what? Parts per thousand. That's it. Alright, that's that. Next one, you can see relative deviation in parts per thousand. Just multiply this by 1000. Then what is average error of the mean and what is standard error of the mean? It's very simple. You see, average error of the mean, average error of the mean is given as dm like this, and standard error of the mean is given as what? Sm. So the formula are what? Are very, very alike. What's average error of the mean or average deviation of the mean? Is what? Average deviation over square root of the number of data that you have. And the standard deviation of the mean is standard deviation all over square root of n that you have. So that is it. The formula, sincerely speaking, they are like they resemble one another. So if you know one, you don't have to know the other. So standard deviation of the mean or standard error of the mean is what? Standard deviation over square root of n. The average deviation of the mean or the average error of the mean is what? Average deviation over square root of n. Now we know all this. So let's start solving questions. So let me tell us how we are going to solve it. I have several methods, but I'll just use one in this video. Okay? Alright. So what do we do here? Firstly, I want to teach us the tabular form method. So this is tabular form. This is tabular form. So you will have, I'm coming. Okay. So this is my x. This is the score we have. So we have x and that's the score. So we have 25.24. We have, oh, I think, let me move my table there, please. Let me move this table to this side. Okay. So this is x. So we have 25.24. We have 25.18. We have 25.31. We have 25.29. And we have 25.38. And we have 25.42. And we have 25.22. So this is what we have. So let me copy that. Okay. Okay. All right. So this is what we have. Okay. So let me just bring this here. Okay. So this is what we have. Now, firstly, we will need to first calculate our mean. Remember, that mean is very, very important. So let us just get our mean somewhere around here. So our mean is what? The mean is x bar equal summation x over n. So that is, I'm to add everything here together divided by n. That is, add everything you have here together, which is 25.24 plus 25.18 plus 25.31 plus 25.29 plus 25.38 plus 25.42, then lastly plus 25.22. Add it together and divide it by, how many are they? We have 1, 2, 3, 4, 5, 6, 7. So there are 7 in what? In numbers. So I'll go ahead to add that together now. So 25.24 plus 25.18 plus 25.31 plus 25.29 plus 25.38 plus 25.42 plus 25.22, and that gives me 177.04 divided by 7, and my final answer will be, so I'll just leave it as 4 significant figures the way I have it here. So leave it as 4 significant figures. So you have 25.29 as your mean. 25.29 is my mean. Okay, this is what I have. So my mean, x bar equal 25.29. So keep this in mind. So next thing on our table will be what? X minus x bar. So that is this values minus the what? Minus the mean. So 25.24 minus the mean, that will give me minus 0.05. This will give me minus 0.11. This will give me 0.02. This will give me 25.29, that's 0.00. 0.38, that will give me 0.10. 0.42 will give me 0.13. And this one give me minus 0.07. Okay, that's 25.22 minus 25.29. Yeah, this is what I have. So after having this, now the next thing is for you to get your absolute value. That is x minus x bar. Get this absolute value. That is, anywhere you see minus, just change it to plus. I just need the main value. Just 0.00, 0.10, 0.13, 0.07. Now the next thing is that what? Get this x minus x bar square. Now funny enough, when you square this, the minus will go away. So 0.05 squared, that will give me about 2.5 times 10 raised to the power minus 3. Also, if you look at 0.11 squared, that will give me 1.21 times 10 raised to the power minus 2. Next one, 0.2. Wait, oh, there's a slight mistake here. This is supposed to be 0. So you have to be careful when dealing with statistics, so you won't run into error. Okay, so 0.02 all squared, that will give me 4 times 10 raised to the power minus 2 minus 4. This will give me 0.00. This will give me 1 times 10 raised to the power minus 2. This will give me 1.69 times 10 raised to the power minus 2. And lastly, this will give me 4.9 times 10 raised to the power minus 3. Let me cross check that again. 0.07 squared. Yeah, 4.9 times 10 to the power minus 3. Now, I've gotten that. So I'll need to get my summation x minus x bar. I will need it, surely. So getting this will give me 0.48 if you add everything together. 7, 8, yeah. Next one also, if you add your summation x minus x bar square, everything will give you 0.0468. 0.0468. Now, this is what you have. I've gotten all this. Now, you see, if you are able to prepare this table, you are good to go. Then, what is my average error? How do we calculate average error? Remember, our average error is what? Mean deviation. And that's what? Summation x minus x bar all over what? All over n. And what is my summation x minus x bar? That's 0.48 all over n is the number of data that you have, and that's 7. And what would that give me? 0.48 divided by 7. That will give me what? 0. That will give me 0.07. That is 0.0, because I have 0.69. So let me leave my answer this way, 0.069. Now let's go. Now, after getting this, next thing is that we want to get the root mean square error. What the root mean square error? That is the what? That is the standard deviation. Don't forget, root mean square error, that is standard deviation. And what is that? That's what? Square root of summation x minus x bar square all over n. And that gives me square root of, what's my summation x minus x bar square? That's what? 0.0468 divided by, this is what? N is 7. So what would this give me? Square root of 0.0468 divided by 7. So that would give me, remember, this is minus 1 because our data is what? Is less than 30. So this should be now divided by 6. That's 0.0468 divided by 6. Then square root of answer. So this gives me 0.0883. So that's my answer for the standard deviation. So next one is, what is the variance? Remember, the variance is the, let me use that in another color. The variance is the square of the standard deviation. Don't forget that. It's the square of the standard deviation. And when you square your standard deviation, here you have 0.0883 square. And what would that give me? So if I square my answer from the calculator, I'll be having 7.8 times 10 raised to the power minus 3. I can say 7.80 times 10 raised to the power minus 3. So that's my variance. Now, what is probable error? So probable error, remember, I can use either of the formula I've written for us for it. So my probable error R is equal to what? My probable error is equal to what? 0.6745S. So I'm using this only. So 0.6745 times, what is my S? My S is what? This is it. 0.0883. So 0.6745 then times 0.0883. So that will give me 0.0596. So that is my what, probable error. So I've gotten this already. So I want to go ahead to erase this table because I won't be needing it again. So I'll go ahead to what, to erase this table. Okay. So let's go. Okay. Now, what's the next one? The next task here is to calculate the percentage relative deviation. So remember that normally relative deviation is equals to what? Standard deviation all over what? All over mean. But since they say percentage, that's times 100. And that was standard deviation, that's 0.0883 divided by what is the mean? The mean is what? 25.29, then multiplied by 100. So 0.0883, okay, 25.29. So my answer is 0. I have 0.349%. That is it, 0.349%. So I've gotten that. Next one is this. We want to calculate the relative deviation in parts per thousand. It's very simple. You see this relative deviation here? Just multiply it by what? By 1000. So that'll be 0.0883 all over 25.29, then times 1000. You know that your units will be different. Can you still remember the units? So times 1000 divided by 25.29. So that will give me 3.49 like this. You can see that? Good. So next one is average error of the mean. What's average error of the mean? Can you still recall the formula? The average error of the mean, that's very simple. That's the average deviation of the mean, which is what? The average deviation over square root of n. And what would that give me? This is 0.069 all over square root of n, and my n is 7. 0.069 divided by square root of 7. So that will give me 0.026. And the standard error of the mean is what? Standard deviation over square root of n, and that will give me 0.0883 all over square root of 7. So 0.0883 divided by square root of 7. So let's see, that should give me 0.033, 0.0334. So this is the answer. You can see. So this is just how to calculate. So they can give you any question twisted or anyhow. So just this is how to just calculate it, and this is the understanding of the video. So try to share to your friends that are taking physical chemistry under and that they will require to know this error. Please send it to them, and try to subscribe to my channel, like, comment, and share. Thanks for watching. Bye.